Hi, I'm Chris Hobson, and I'm an undergraduate from the VCU Center for Environmental Studies. And with me today is my colleague, Grace Lumsden-Cook, who is also in the undergraduate program at VCU Center for Environmental Studies. Today we'll be talking about the use of smartphone applications and panoramic 360 imaging as new tools for evaluating scenic landscapes.
The United States is home to many unique scenic landscapes, ranging from California's redwood forests to the white sand beaches in Key West. All of these scenic resources have an intrinsic value that must be effectively managed in order to be preserved for future generations. According to the Department of Interior, in 2019, visitor spending in communities near national parks resulted in a $41.7 billion benefit to the nation's economy and supported over 300,000 jobs. Scenic viewsheds cannot be overlooked, as they are a key economic resource for communities across the country.
The Virginia Scenic Rivers Program began in 1970 when the General Assembly passed the Virginia State Scenic River Act. Since then, more than 900 river miles, labeled in dark blue, have received scenic designation by the Department of Conservation and Recreation. There are not only ecological benefits to designation, but economic ones as well. Lands along the river corridors that have been designated can have decreased tax liabilities and can be eligible for grant funds.
Traditional methods for scenic evaluation rely upon a group consensus-based approach in order to reach a qualitative score for segments under potential designation. They must be done in the field and on a river that is at least 5 miles long, publicly accessible or listed in a standard canoeing guide, and have identifiable start and end points. Under the supervision and expertise of Lynn Crump, a small group of students enrolled in VCU's Freshwater Fridays course were educated on the traditional method.
Traditional approaches rely upon a qualitative, consensus-based approach to score focal segments, which are hard to duplicate without any prior knowledge of scenic evaluations. Also, traditional methods are quite static and don't record the changes in the river over time. The goal of our study was to develop a scenic assessment approach that addresses these challenges by integrating traditional assessment rubrics, geospatial data collection using smartphone deployable applications, and panoramic imagery, similar to what you'd see on the street view of Google Earth, with the goal of introducing a data-driven methodology leading to quantitative results.
We piloted the approach on the New Canton to Columbia segment of the James River, which is located in the Piedmont region of Virginia. But how do we go about remodeling the traditional approach?
Taking the existing protocol and converting it into ArcGIS's Esri Survey 123 application, it allowed us to collect in-field data which can be directly uploaded into a cloud database. Continuous sampling of the visual elements allows for quantifiable comparisons of scenic scores along the focal segment.
This is a screen recording of the Survey 123 app, developed for the purpose of rapid assessment taking in the field. Notice that geospatial location, photos of the viewshed, as well as date and time stamps are embedded within the app.
Surveying in the field, as well as on Survey 123, has its limits to what can be observed. It is common that sections of river up for designation are habitats to endangered species, as well as historic landmarks that can't be seen from a canoe's perspective. Specific to the New Canton segment, various endangered species of mussels, birds, and fish are present. With regards to historical development, John Smith published this map in 1624, displaying the capital of the indigenous Monacan tribe.
Traditionally, each person who is evaluating a segment used one paper to make note of structures and crossings along the trip. Once the section is floated, all of the observers come to an agreement about the visual criteria. It is then combined with the non-visual criteria, which makes up the Virginia Scenic Score. In the approach we piloted, each observer takes multiple samples along different portions of the river. This allowed us to move from a qualitative approach to a data-driven approach, where we can find the average of scores along a given segment.
We were given the opportunity to collaborate with Terrain 360, developed by Ryan Abrahamson, a company providing virtual, high-quality panoramic imaging of trails, waterways, and landscapes throughout the United States. When floating the focal segment, Terrain 360 accompanied us and recorded multiple virtual tours for our use in at-home desktop analyses.
This short clip displays the high-quality panoramic views provided by Terrain 360, simulating a realistic in-the-field experience.
Because the entirety of the James River has been virtually mapped and archived by Terrain 360, we were able to virtually float it from the headwaters in Clifton Forge to the confluence of the Chesapeake Bay.
James Von Esch kindly provided us with a demo of what at-home or virtual surveys look like. As long as you have access to a laptop or monitor and a smartphone, a virtual survey can be completed. With these tools, in-the-field surveys become repeatable in the home environment.
We wanted to answer these two questions. Does this segment of the Middle James River have a higher, lower, or similar Virginia Scenic score relative to other random view samples of the Middle James? As well as, do virtual and field assessments result in similar or different scenic scores?
We utilized R, a statistical software, in order to answer these questions.
Using the Esri USA Rivers data layer, we identified 30 random points along the Piedmont James River between Clifton Forge and just before the falls of the James River, outside of Richmond. Those random points were visually scored on Terrain 360 and recorded in the Survey 123 application.
After looking at the scores from the desktop analysis, we found that the focal segment had scenic scores that were 13% less scenic than other random parts of the Piedmont James, though these results could be skewed due to a lesser number of random samples being taken compared to the number of focal samples.
Initially, we expected the virtual and field scores to be the same and thus have a positive correlation.
Instead, we saw that there is no significant correlation between the two. The lack of correlation could be attributed to the fact that it was the first time that the observers scored in the field and virtually, so there could be a learning curve for some individuals.
The Survey 123 app has the possibility to be utilized and deployed in a variety of scenic landscapes, waterways, and byways. In fact, the app has the Bureau of Land Management, Virginia Scenic Protocols, as well as the Virginia Scenic Rivers criteria within that can be utilized in surveying other scenic landscapes. We've piloted the use of two innovative technologies which have the opportunity to transform how scenic landscapes are traditionally surveyed. These technologies have opened the door to quantitatively comparing scenic scores. Although the conclusions from the field versus virtual analysis show that there is no significant correlation currently, continued research and development could lead to it becoming a core management practice of scenic surveying. From our results of the random versus focal analysis, there is promising evidence that Terrain 360 could be utilized in the future as a reference tool.
We would like to give a special thanks to the Freshwater Fridays students. This project was a collaborative effort and could not have been done without the help of the following individuals: